Hey, welcome to part 2 of Design Programming's Week 2 lecture. We're going to cover loops here in a second, but firstly, I want to tell you I've just discovered something that makes me incredibly happy. In between parts 1 and 2 of this video, I stopped for a lunch break. I spilled pasta sauce on my shirt. But you know what makes me amazingly happy? It's below the crop, guys. Everybody, it's below the crop. You don't know that I made a mess of myself. How great is this? Let's get into it. Loops are the other major kind of control structure in programming, where conditionals allow you to decide whether or not you're going to execute some code. Loops allow you to execute a piece of code multiple times. So the basic way to think about a loop is that, and we're going to focus entirely on for loops in this course. There are other ways to loop through code, but effectively what this is a block of code. In here, you can do whatever you want in between these two curly braces, and a block of code which has 3 statements all sort of smushed into these parentheses at the top. So the important part here is the test. So you are going to keep using this code over and over again until this test is false. So it's a bit like an if statement, which just has a test and runs once, but in a for loop, it has a test that runs many times, and before it runs the code, it checks it again. So you can sort of think of it as a little bit like an if statement that just keeps going while it's true and then stops when it's false. Now, of course, the test needs to change every time, and that's where these other 2 things come in. So inside this little loopy, inside these 3 statements here, you're going to create a variable, you're going to have a test for that variable, and then you're going to have an update. So effectively, after each time you go through the loop, this bit of code is going to run. Usually that makes a number higher, and then you get a little bit closer to stopping. Let's look at an example. So if you wanted to draw 10 lines using, hey, I'm not actually sure if this is 10. Let's have a little quick count. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Hey guys, it's 10 lines. Awesome. If you want to draw 10 lines using what you learned last week, it'd be pretty straightforward. You're going to have to just draw 10 lines, right? And you have to make this bigger. This is where it appears on the x-axis. Every time you're just going to add 50. That's sort of doable with copy and paste in 10 lines. But what happens if you wanted to draw a grid and you wanted to draw 200 lines? Or you wanted to make them resize with the screen? It's going to be kind of a nightmare. But with the for loop, we can just write the line once. And we're going to use our variable in here. So where does this variable come from? Well, that's I. It's what comes up here. So the first part, we're defining our little index variable, which is this thing that goes that is part of the loop. So in this case, I, which is just a shorthand indicator for index. You can call it whatever you want. That's just kind of a convention. So we're going to start with I is 50, which is the same place we started with up here. And then our test is I less than or equal to 500? If I is still less than or equal to 500, then we're going to keep going. But after every loop, we are going to add 50. Now, you might not have seen this plus equals thing, and it wasn't listed on my little comparators. You can just do I equals I plus 50. So I is whatever I used to be plus 50. But you can also just shorthand I equals I plus to I plus equals. Honestly, if you don't really understand what I just said, don't do that. I equals I plus 50 will get you there every time. Eventually, you're going to learn that programmers are lazy and like writing as few characters as possible, and sometimes it's okay to be shorthandy. But this executes exactly the same as this. It runs exactly the same way. In fact, as far as the computer's concerned, they see line 50, 50, 50, 500. So just like that first one. And then it goes through all this, adds 50. So now I is 100. And now it draws line 100, 50, 100, 50. So exactly, 150, 100, 500. So exactly the same as this one. And then it goes and adds 50 again. And then it does this one. and so on and so forth, each time testing to see if I is still less than or equal to 500. Until it isn't, it'll add 50 to I will now be 550, I is no longer less than 500, and it stops. And that probably sounds confusing, but effectively what we're doing is we're just making I bigger every time, which allows us to execute this code one after the other, and then finishing when it's too big. So things start to get a little bit complicated quickly, but let me see if I can walk you through this, because of course you can combine if statements with for loops, and for loops with for loops, and if statements with for loops with for loops. You can go as deep as you like. The kind of expected way of doing that is to indent your code for each block that you're in. So we're now from here, all of this stuff is inside that first for loop, so we can just neatly drop that in, and then we create this second for loop inside that for loop, and we're going to drop into that and indent our code again. You can just do that by hitting tab. There is a clean up your code button in both the p5.js editor and the CCC's editor. You can use that to just do it for you. It will identify where the blocks of code are and then indent them in such a way that allows you to keep track of how far in are you, how many layers into your code are you. This is a super useful way of keeping track, and I really, really, really do not want to see any assignments where your code is not indented. It might seem arbitrary to you, but trust me, you'll love me for it later if you get into the habit now. What this does is use one ellipse call to draw however many ellipses fit on the screen in a grid. So let's have a little look what we're doing here. When we draw the ellipse, we use the x variable for the position along the width of the screen and the y variable for its position in the height of the screen. So we're effectively going through a grid here. Both of them start at 100, and both of them increase by 100 each time you go through the loop, and then they stop at width for x and height for y. So if we think about it, we draw this one first, right? So it starts off at 100, 100. We get down to here and draw ellipse 100, 150. That's this fella. And then we're going to go through this middle one. So right, we don't go back out to the top one because we're stuck in this block now. We're stuck in this little block, and we're just going to loop through it until it resolves. Remember, computers go deep. So you're not going to zoom back out and do the other thing. The computer is now stuck here. And like a 4-year-old with a favorite toy, it is going to just do this over and over again until it gets bored. All right, so imagine your computer is a particularly energetic 4-year-old. You're going to do this until this stops being true. So that means you draw, you move over by 100. Oh, I'm a goofball. Okay, yeah, we are actually iterating height first here. We start with x. Now we're going to draw this. See, I'd assumed we were doing rows, but actually reading the code in more depth, we're doing columns. So we still draw this one first, and then we're going to increment y. So it's now 100, 200. And that's this one here. We are now going to draw this circle. And then it's going to be incremented again, 100, 300. That's this one. 100, 400. That's this one. And then 100, 500 doesn't fit on the canvas. So now y is 500, and that is apparently greater than height. However many pixels this is, you can inspect and look at exactly how many pixels there are on your canvas, but you can also resize this and it'll draw more or less. And it is now over this one, and we're going to finally exit this first loop. What are we going to do? We're going to bounce up here, and we're still stuck in this one. And this time, we're going to increment x to 200, and then come back in here and do all of this again. So now it's 200, 100, because we create y from scratch. This is a new variable y, because we're going to let y equals 100. We've recreated it again. So now we're drawing it 200, 100, and a size of 50, and that's this circle here. Then 200, 200, 200, 300, 200, 400, and then what do you know? 200, 500 is off the screen, or rather 500 is still less than height, because height hasn't changed. And we're going to finally get out of this block leave out to this next one, and then increment y by 100 and go right back in. So effectively, every time the computer gets into this inner loop, it's going to draw a whole column of circles, and then it's going to back out to the outer loop, move over by 100 pixels, come in and draw another loop. So I know this seems weird, it's jumping backwards and forwards and going everywhere, but really all it's doing is imagine you're giving instructions to a very simple drawing robot. You say, draw me a line of circles. When you've hit the edge of the page, move over and do it again. Continue doing this until you hit the other edge of the page. Because of course, once X is incremented, let's draw in this case 6 columns, X gets up to 700. 700 is clearly more than the edge of the screen here. And it fails this test. 700 is not less than width. So it goes outside of this block, skips it, goes down to here, and finishes the code. Ta-da! We have a grid of circles. Get that? Nested for loops. It's a hugely powerful concept that allows you to do so many things, especially when it comes to drawing interesting generative art like we're going to want to do for some of our assignments. Nested as in Russian nesting dolls, right? One nested inside the other. The loops get nested. One inside the next, inside the next. This is going to be gone through in much more detail in the tutorials. I just really want in the lecture to expose you to the concepts. So if you don't feel like you get it, then that's because we don't really remember that many things that we hear and see. We're much more likely to remember things we do. And that's why you should do your homework. So let's see what else we can do with this. Well, it turns out there is a really convenient function. And there's a lot of text here describing it that I think is something that you should come back and refer to later as you think, oh, that map function, how did that work again? There's a spelling error in this slide. I'm mostly using the slides from last year. You know what? We can't be having this. Okay, just pushed a hotfix to the website. Can't be having that. Let's refresh the page. Boom. There we are. Yeah, that's the trouble with working with someone else's slides. Okay, where were we? The map function. The map function is an incredibly convenient way to move between one range of numbers and another. So if you've got a number that's between 0 and 1, or you've got a number that's between a 0 and width of screen, and you want it to be between some other numbers, so like the speed of an object or the color of an object, it's just kind of annoying basic maths to be like 4 times the width of the thing divided by 255 because that's how many colors there are. It's just kind of annoying. It is much easier to think about this in terms of map this range to that range, as in however many % I am through that range, which might be 0 to 256, map that to however far I am through this other range. It might be 0 to 1 or 0 to width or 100 to width or whatever. So this lets you do stuff like this, which of course you could do without the map function, but you'd have to work out the arithmetic. And as I said earlier, programmers are lazy. The laziest way to do something, assuming it doesn't create unnecessary maintenance, is usually the best way. So let's have a look at what's happening here. No stroke just turns off outlines. That's something that you probably learned last week, but just to remember. So we're going to create this new x position variable. We're going to take the mouse x variable, which is currently in the range of 0 to width, right? And we're going to map it from the range 1/4 of width to 3/4 of width. Remember this from the first video this week. This maps, this equates to 3/4 width. So that's 1/4 width times 3. So 0 to width mapped to width 1/4 to 3/4. So what does that do? Well, when we move our cursor from all the way over here on the left of the screen, it draws the white circle that is already at 1/4 of the way. As we move across, we meet up in the middle because halfway from all the way over to the left to all the way over the right is the same as halfway from 1/4 to 3/4. But then it moves slower than us, so by the time we get over to the far right edge of the screen, it's only on the 3/4. In other words, it's traversing the middle half of the screen whilst we traverse the whole thing. And you can see the two circles above it are just traversing from the beginning to halfway and from halfway to the end. So they move at the same speed, they just start and finish at different places. You can achieve that without just changing a couple of things in the mouse X. This sounds a little complicated, but the truth is, if you get your head around it, it'll make it a lot easier for you to draw things that move around within the screen. Now, the color that you draw it should be from 0 to 255. In this case, from, I believe, 0 is black and 255 is white. If that's the other way around, then whoopsies, I'm sorry. It changes in different places, and I've been programming in other languages most recently. But we want to say, all right, well, 0, so 0 pixels across our screen is white, and then all the way to the other end of our screen is black. You could do that by calculating the width and then figuring out how many pixels that was, dividing the number by that to get something in between 0 and 1, and then multiplying that by the colors. But that requires several bits of maths. You could just go map mouse X from the range 0 to width into the range 0 to 255, and then fill with that color. Boom. Much easier. Get your head around the map function if you can, because it's something that will save you a lot of time later on. But let's have a look at how do you use map to make something interesting. All right. Sometimes we don't know how wide a screen is. Have a look at this. We want to draw 5 circles. All right. This remaps the variable, which is just 0 to 5, right? In this case, we're not going through the number of pixels. We're just going through an index number, circle 0, circle 1, circle 2, circle 3, circle 4. And we want to then map that into where on the screen are we. Because we might also want to map that to color, or we might also want to map that to size. And if we were running those loops like we were a second ago, like we were with these ones, where you see the loop index is incrementing by 100 each time, it would sort of be really annoying to do like, oh, I need to work out how many pixels, what does that mean for the color, and have to divide by the width of the screen and then multiply by the color space. So instead of doing that, whoops, went too far. Instead of doing that, we're going to do a map to get it into the width space. In this case, okay, we've got a number that is between 0 and 4, and I want you to map that to between 100 and width minus 100. So the first circle is drawn at 100, and the last circle is drawn at width minus 100, and the computer just figures out how far apart they have to be. Right? So you don't have to do any arithmetic. If I resize this screen, there's still 5 circles. They still start 100 pixels in, and they still end 100 pixels from the right-hand side. We just know that every time it draws, it's deciding how far apart they should be. Contrast it with this other loop where we're going 100 pixels across each time, and that's just going to draw, in this case, 6 circles. But if we make the screen smaller, it's going to draw fewer circles. This time it's only drawing 3. Now a 4th one gets added, now a 5th, and so on. So if you do it this way, you have a fixed number of iterations, right? Because you know I is going to go from 0 to 5. In this case, it'll stop at 4, right? Because when it's 5, 5 is not less than 5, so it'll stop running. So you do a fixed number of iterations, a variable distance apart, or a fixed distance apart, but a variable number of iterations. You're going to get a chance to play around with these in some of the challenges today, and trust me, once you get your fingers dirty, you'll sort of start to understand what's happening here. It's one of the best parts of programming in P5.js is just kind of, if you can't figure something out, just do it. Draw a bunch of circles. If you don't know how nested for loops work, just draw a bunch of circles with them. It should be pretty clear. If you don't know which one's getting drawn first, make them get lighter each time. And you'll be able to see pretty quickly which ones are the dark ones, which ones are the light ones. Some of your experiments might even look cool. So here's something that I think looks cool. We've been looking at mapping colors. We've been looking at mapping sizes and mapping positions. Let's map some colors and make ourselves a wacky gradient. What this is doing is drawing lines, but each line is a slightly different color. And because there's a very small difference, row to row, this does look like a color gradient. So what are we doing here? Inside our draw loop, we're going to have a for loop that goes from 0 to height, going up by 1 each time. By the way, we talked a little bit about how I plus equals 1 is the same as I equals I plus 1. Well, I plus plus is even more lazy than that. I plus plus is I plus equals 1, or I equals I plus 1. Anytime you see that, it's just saying add 1 to I. You can have I minus minus as well if you're in particular need for that. These are absolutely not necessary to mastering the language. They're just neat little shorthands. Okay, so we're going to create this color called color changing. And we're going to map between the height range, so that is between 0 up here and whatever height is down here, probably something like 480 or something pixels, just judging by the size of my screen. And so whatever percentage we are in that space, we're going to map to the range 255 to 0, which happens to be the range of the color space that is used by P5JS. We're then going to draw a stroke, and our stroke color, because when we specify stroke with 3 arguments, it sets a color. This is the red channel, the green channel, and the blue channel. And so the red channel is going to go from 255, the maximum, all the way down to 0, the minimum, but it's going to be using a moderate amount of green and a serious amount of blue. And so this is the color you get at max red, small amount of green, reasonable amount of blue. And this is the color you get at no red, small amount of green, reasonable amount of blue. Have a mess around with these, have a mess around with the way it's mapping, and you'll be able to do gradients between other ranges. I know there are plenty of you out there who are massively more capable visual designers than I am. Make your coolest gradient. Gradients are cool again, right? We went through 5 or 6 years where flat was the way to go. But now I think maybe a subtle gradient can add a bit of pizzazz. It's possible that pizzazz is not a cool word. Oh well. One more thing I want to cover. Just another little convenient trick that you can use when you're iterating through stuff. Sometimes it's helpful to know the remainder when you divide something. Modulo, or the modulus operator, is a shorthand for how many are left. What is the remainder when you divide x by y? So 10 modulo 2, in this example here, 10 modulo 2 is 0, because when you divide 10 by 2, you get 5 with none left over. Right? High school maths, everyone remember? It might even be primary school maths at this point. But we're now looking at not what's the answer in 10 divided by 2, 5, but what's the remainder? The remainder, in this case, is 0. 10 modulo 3, the remainder is 1, right? Because 10 divides into 3 times, but with 1 left over. This is mostly useful when you use it in conditions, like it's being used here. So here we have one of those fixed number of iteration for loops. So this is going from 0 to 10 and adding 1 each time. And then we're mapping that. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then it doesn't go a 10th time because 10 is not less than 10, right? So we're going to do this block of code for 0, then for 1, then for 2, all the way up to 9. And then we're going to create this xpos variable, the x position, and it's going to be based on I, but where I is in the range of 0 to 9, we're going to instead put it in the range of 100 to width minus 100. So we're going to go in 100 pixels and start there, and then we're going to evenly space 10 of them until the end, which is 100 pixels from the right. Again, if this doesn't make sense, it might be helpful to scroll the screen, resize the window, and you see that those lines always start 100 pixels in from the left and end 100 pixels out from the right. Then what do we do with that exposition? Well, we're going to eventually draw a line there, but first we're going to change our colors. If I, so that's our index variable, 0, 1, 2, 3, etc., modulo 2 is 0, I'm going to evaluate this, I modulo 2. Well, when it's an even number, I modulo 2 is going to be 0. But when it's an odd number, that odd number, 1, 3, 5, 7, etc., divided by 2, the remainder is going to be 1. The remainder when you divide an odd number by 2 is 1, which means 1 is not equal to 0. We're going to do this. That is to make a dark, almost black stroke. Remember, a stroke with one operator is grayscale. So you put one parameter in there, it's a grayscale. When you use the 3-parameter version of stroke, it's going to interpret this as red, green, and blue. So in this case, max red, no green, no blue, which is to say red. So when we have even numbers, that even number modulo 2 is 0, and we draw a red line. Or either we set the stroke to red and then down here draw a line at that position. And when the number is odd, we set the stroke to almost black, very dark gray, and draw a line. The lines get drawn in the same line of code every time, but it's just the even lines, lines 0, 2, 4, 6, and 8, are drawn red, and the odd lines, 1, 3, 5, 7, and 9, are drawn very dark gray. So that's where I want to leave it for this week. I know we've covered a lot of ground in this lecture. We've covered if statements, that is conditionals, in the previous video, and then we've covered a couple of examples of those. And then in this video, we've covered for loops, that is iteration statements, and we've covered the map function, in other words, a way to get from one range of values to the same percentage through another range of values, which really just saves you a bit of maths shorthand. And we've learned about the modulo operator, which again is a little bit of maths shorthand that gets you the remainder when you divide by something. All of these things are maybe a little bit overwhelming, in which case, get in there, try them, sort of see what these things do, put some nested loops in and put in a modulo in one of the conditions or something or other. Find out what happens. The only way to learn things is to muck around with them. And this subject is built 100% on mucking around. I'll see you in class.